also to let you know if we run something similar next term or the term after or next year. So if anybody didn't write their name on this list and would like to add it. Yeah, okay, there's a little stuff. We talked a bit about what things would look helpful for, like what are helpful directions to aim at from the perspective of trying to achieve good long-term outcomes. And so I'll start by looking at this question: when is progress good? It looks like maybe it's something about the word progress that I'm using there, but generally it seems in society and life, getting better at doing stuff seems to be extremely good, and this is something which has contributed to the world being way better today than it was 100 years ago, and I think by most measures, like a lot better 100 years ago than it was 200 years ago, and like we have, people just have much higher quality of life, at least on average, and longer life expectancy, and we're able to do a lot more things than we used to know how to be able to do, and looks like it's a reasonably good direction. So our default answer should probably be, okay, progress in most domains looks pretty good. But let's have something we've been trying to do in this course is to take look at this very big picture question and look, okay, in the whole space of things, where could we be going? And actually, what does that picture of what the long term might look like tell us about some shorter term things that we could be deciding on? So we can see whether that gives us any different perspective on progress. And Toby Ord talked a bit about this back near the start of the term, and he was looking at actually some of the very valuable futures that he thought perhaps humanity could attain if we could go out and colonize the stars in our galaxy, or possibly even in other galaxies. And that does look extremely valuable. But if we think that looks extremely valuable, then clearly we need to continue progress, because if we stopped progress, like, we are not going to get there. And so that would itself potentially represent a bad outcome in terms of the opportunity cost, having lost this fantastic large opportunity. But it's also there's also this astronomical waste argument that actually, because the universe is expanding, the longer we delay, the less star systems we're going to be able to reach. And in fact, the ones which are going out of our possible future reach goes up at quite a high rate. Do you know the number off the top of your head on this?
Not off the top of my head right now, but
yeah. I think it was, depending on how fast you assume you might be able to travel, it might be of the order of a solar system per second. So it's, if we think, well, there's a big opportunity cost of not getting this stuff, then that looks like it could be an extremely large opportunity cost, not just of not having progress, but of not having progress as fast as we possibly can. So at that level of argument, it looks like progress is still good. In fact, might be even better than we'd initially thought. But then we saw this argument that in fact, there are plausible routes where our future develops so that we do go out and spread through and reach some kind of technological maturity and produce very valuable futures. And there are also plausible routes where we don't do that, which we loosely group together under the title existential risk, and including scenarios where we have human extinction and we lose the value this way. And if that's the case, and there might be routes to push from being on one of these courses to another, then that is probably a larger source. Even if we can only make a very small effect of the probability, that's probably a much larger source of value than trying to accelerate. These numbers of one solar system per second only look large when we're used to a universe with one solar system being the kinds of things we can affect. If you're actually going and you already have billions of galaxies, one solar system is a very, very small amount proportionally. And so if there's something which might risk that opportunity of billions of galaxies, then that looks like it's worth paying serious attention to. So this is what gets us to, that's like a recap of things that we were talking about earlier in term, and gets us to the assumptions for the question that I now want to pose and investigate a little bit, which is, if what we're caring about is the effect on existential risk, when is progress good? We know that still progress overall must be good, because we know that halting progress totally would be bad. But it doesn't follow that all progress is always good. So let's explore this. First of all, here's a simple model, which is that risk is incurred by being in a state, and the amount of risk that you have depends on the state that you're in. So when you're this is some level of progress, and this is an extremely simple model because I'm compressing all kind of axes of progress down to a single dimension. And I think that, like, obviously that's false, but sometimes these extremely simple models are helpful, and you can actually understand, well, this seems like it captures the major dynamic. And so obviously simple models are easier to analyze. So it's often, I think, worth starting with the extremely simple one, understand the behavior there, then understand actually how do we think it's wrong and how can we push on from that. And then I'm going to assume that, right, there's a certain amount of risk per unit time, and probably this starts quite low and fairly constant, where we don't have any, these are the kind of natural exogenous risks. Maybe we could be wiped out by a large enough natural disaster. Maybe we could be wiped out, so like by an asteroid hitting the Earth. And indeed, perhaps as time goes on and we make more progress and we build a bigger economy, this risk shrinks slightly because we're spread to more places in the world. We're a little bit more robust. We can survive a larger catastrophe. And then there's the hypothesis is that we're in a period at the moment where this actual risk per time might be increasing, or at least say that it was higher in the 20th century than the 19th century because of the development of nuclear weapons. That was this powerful technology, which meant that actually we were in a position to do things which could have truly global impact, where we haven't been before. And in the general trend of improving power of technologies, that might well increase. So I can't claim that this is entirely smooth, but I'll draw some model where this is increasing. And then presumably at some point in the future, we will, if we make enough progress, we will have discovered all the particularly strategically important technologies which might pose dangers. And we've also, if we haven't experienced an existential catastrophe in the meanwhile, we've also worked out what social infrastructures or mitigating technologies are needed to reduce the risk from these things. So eventually, this will cap. I don't claim it has to be. It actually has to be unimodal, but kind of from a position of ignorance, it seems plausible. And then it asymptotes off to 0. So in this case, what you want to do is, with this really simple model, you want to just actually move through the progress as quickly as possible, because that way you have less exposure to risk if you can move through. If the rate at which you're moving is not just a function of where you are, maybe what you'd like to do is you'd like to get up to here and then somehow pause so that you can sprint through this bit. But it's kind of unclear when we set up this model whether that's a permissible strategy or not. So we at least get some perspective that faster progress still looks good for reducing risk, from reducing this time that we're exposed to different things. It might not help with some risks. If there's a risk of adaptation, making sure that we adapt to a new technology and get it right first time, then it might be less that it's this question of what period we're exposed over, and more a like single spike of risk of did we get this right first time or not. But it's a simple model. I think we can like at least see the direction it's pushing. Okay, now what happens if we try and split out progress into more dimensions? I will go for 2 dimensions because it's nice and easy to draw on a whiteboard, and it's the first number of more than 1, and in particular because it's enough to illustrate the point that I want to make. So now I'm going to have 2 dimensions for this, which are different dimensions of progress. So we'll have kind of technological progress here. And here I'm going to put coordination. Now both of these are again a little bit vague, but by technological progress I generally mean the ability to like build more powerful technologies and use them to do stuff. By coordination I mean the and I like physical technologies, like the stuff that you build, not social technologies like democracy. There's some sense of technology which includes those things. By coordination I mean the ability of groups, and particularly maybe small groups of people, but also countries, to coordinate and achieve common goals and fail to leave kind of gains that could be made from trade on the table, or fail to, and that can include ending up in tragedy of the common situations where they fail to trade properly so that they all cap their emissions, even though because the individual incentives are better for people to continue doing this. And then if we think about what the amount of risk is, I'll try and demonstrate on this on the diagram with some density of green. At some low level of technological progress, we just think the risk is like fairly low everywhere, not too dependent on this coordination vector. This was where we just don't have the technology which might be able to threaten us. But as we get more technological progress, and for some kind of levels of power of thing we can do, it may be actually extremely important whether we have good coordination or bad coordination. So at the point where we have thermonuclear weapons, if these are all in the hands of individuals and it's basically an anarchic world and we don't have states, it seems like we could have a lot of danger over here. And if we're over in a case with kind of good world government, or like really good cooperation and coordination between countries, it looks like there's pretty much no chance of ending up with an accidental war here, and this looks pretty good. And then it'll be, it's fades in between these somewhere. And in general, the picture here is this top left corner looks extremely dangerous. The top right corner looks very good. It's becoming more dense as we're going up here, less dense as we're going up here. If we're perfectly coordinated, then we're not really worried about these anthropogenic risks where we're generating them ourselves through more powerful technologies. It's only actually about the more powerful technologies help us to escape from the natural risks. So maybe space flight and colonizing other planets could reduce lots of risks where something accidentally happens to Earth and we can't live here anymore. And in between, well, it's in between. Okay, so what's the relation between this and this? This is somehow a compression of these together, and so might be representing a middle path up here, and what's going on there. But over here, now we can think, well, ultimately we're going to end up here. This is the aim, is to be really good at this stuff and really good at this stuff. So if we get here, everything's good. But there's different ways, perhaps, that we can get there. There's different trajectories that we can follow through this space. So we could take this path, or we could take this path, or we could take this path. And it's fairly obvious that different paths look like they might have different risk profiles associated with them. And so if we're now thinking about, okay, what's the total risk associated with a development trajectory, it seems like it will still depend on the speed, because we'll still have this argument that if you can go along the same path faster, then you have less exposure to the risk along that path. But importantly, it will also have perhaps quite a significant dependence on the route that you take through this space and this choice of trajectory through here. So in particular, this path, which doesn't look so good, is, well, we just get more and more powerful technology and we leave working out how to coordinate between ourselves to avoid misuse until later. Whereas this path is, well, we work out how to coordinate and get good, stable coordination mechanisms first, and then we get the technologies which would only pose a threat if we were poorly coordinated. So, I'm just putting it in words, and it like maybe sounds sort of obvious that the second one looks less risky than the first, and this diagram, it's a cartoon of what's going on. I find it helpful for understanding, okay, there's the sort of structure which could produce this behavior. So then that gives us a question. Is it better to, I think, okay, so the plan is we would like to end up here with maximal probability. We can try and affect this by trying to affect the way that we progress. Is it better to try and push on the trajectory that's taken, or the speed that we go along that trajectory? And I don't think there's a kind of first principles answer to this. It seems like it depends on which has the greater effect on total risk. Maybe you think, well, actually, the diagram does look a little bit like this, but it's only slightly more dense over here than it is over here. And there's not too much difference. And perhaps because you think actually most of the risk comes from the natural risk, which is not too affected by the coordination relative to the technological progress. I think that actually it may well be significantly more affected by the choice of path, at least among some possibly relatively extreme paths, than on speed. It doesn't seem hard to me to imagine a like plausibly well-coordinated world versus a poorly coordinated world. Kind of both of these within the envelope of things where I could say, yeah, that like maybe the world will turn out like that. So that the worst coordinated one is almost an order of magnitude more likely to have a bad outcome than the well-coordinated one. It seems like coordination actually factors into a lot of the different ways that things can go wrong. So, but I'm appealing to my personal intuition here. I'd be more than happy to have a conversation about this. I think it's like helpful for me to share the bits where I think it and I have an argument versus I think it and this is just my impression, and that this is why what I'm doing with that. Also on the ability to affect speed versus direction, I think maybe we have more ability to affect the direction than the speed, because there's a lot of resources already in society that actually go, hey, progress is great, let's have more of this, and that are devoted to trying to produce more progress. Like this is both it happens organically because there are incentives for firms to produce this at a local level, and it also happens because governments go, look, this stuff is great, let's have more of it, and take actions to try and produce that. And I guess public funding of science is an obvious one here, but I think there are lots of slightly less direct routes for that. And so, and there's maybe, well, some routes that you might think, well, this route would look good. It could just be extremely hard to push on. But there at least looks like there are some things where there just isn't that much effort being made either way, and therefore sort of people are pulling in. There are issues where there's either it's kind of everybody is pulling together to try and make more progress. It looks like you don't do proportionally that much more by going and pulling yourself, or you can have politically contested issues where there's a lot of debate and a lot of feeling on both sides, and again it looks like it's not that easy to make movement on things where there's people pulling in both directions. And if you can pull sort of orthogonally from that, that may be easier. So again, I'm giving you some rough reasons this doesn't, why I think it may be easier to shift the trajectory than the speed. I don't have anything super robust there. So let me mention this notion of sustainable trajectories. I just want to give this as a framing which you can use. People people talk about sustainability sometimes, and often they think about like we should aim for a sustainable world. This is one of Bostrom's observations, that actually there's a lot of things which change in the world, and a lot of things change for the better, and there's a lot of things that we want to change for the better. So we shouldn't, it's probably better not to think of a sustainable world in the sense of a world which we can keep in that state and will remain fixed. Because that would mean cutting off a lot of this possible future value where we manage to achieve things which are a lot better than we can today. But sustainable in the sense of a trajectory that we can stay along, and we're not going to crash and burn off this trajectory because we've used up too many critical resources or whatever happens there. So yeah, it's just a comment that you can think of this, casting it in terms of trajectories, as a sustainability issue. Okay, this gives us the principle of, if you roughly think, yes, affecting the trajectory may well be a better thing to try and do than affecting the speed, this gives us this idea of the principle of differential progress, where we generally we're not going to be able to just stop development of something forever. And or at least that looks extremely hard to say, well, we could make the difference in the entire world history between getting this technology or never getting it. But because there's like, assuming that things continue going fairly well in the future, there'll be a lot more people working on all kinds of areas of research, and that gives different ways for this. But what's more plausible is that we can change the time at which different things are developed, and therefore change the sequencing of development. And so this is a sequencing issue, because we're saying, well, let's, like very crudely, let's get the technology which moves us from here to here before the one which moves us to the right before the one which moves us up, if you kind of think of this as two technologies. Of course, it's nowhere near two technologies, but maybe we can aim to change the sequencing. And if so, it's probably what we want to do is to slow down the development of technologies which might particularly pose risk, while accelerating the progress of things which might be coordination, might be other technologies which could help to avoid or mitigate those risks. And there's a number of complications here. Firstly is that some technologies might well do both. So people have talked about risks from artificial intelligence, and this does look like something where it's potentially, if you develop it and you do it in the wrong way, it could be a catastrophe, and it could be very world-changing. But it's also the kind of thing which could be world-changing in a positive way. It could be that artificial intelligence could enable much higher levels of wealth, which could allow us to avoid some whole classes of catastrophe, and also allow much higher levels of coordination, which could help us do very well on other things. So sometimes this is complicated, and it's not clear whether, therefore, it's on balance good to speed up or slow down something like artificial intelligence. Another comment is that typically we have better levers for accelerating things than retarding. And this is partly because if you're trying to slow something down, you naturally have opponents for that, who are the people who were trying to do it. And so it's hard work to try and do that, whereas it's easier to go and say, okay, let's all get together and do this, or you don't. It doesn't need to be all in the world, but some small group of people go and do this and push forward on capabilities and sort of look like they might be good. So maybe, I guess, you could choose not to do that for some technologies. That's in some sense a way of retarding, but it's a thing where you're choosing not to do the active acceleration rather than active slowing down. And I think that often there are better levers for that accelerating than slowing down. That's also looks like it's, when we're not sure, it's often better to push on because it's less controversial to accelerate things. And it could be that we could create a lot of ill will and perhaps unnecessarily by going and pushing on things, pushing to try and stop some things. Then, so point 5 on the notes here, what directions are robustly good? I think improving and increasing coordination and cooperation is generally good. Maybe you think there's some general things like insight or wisdom which help us to understand actually what directions the things we're doing in push. I think it's like a little bit this thing is a bit underspecified, and so I'm sort of not particularly happy pointing to it and saying yes to that, but it's important enough that maybe it is worth thinking about. And also, actually just an explicit focus on safety. Maybe there's ways that this can backfire, but at least like it looks like that is the kind of thing which would be good to have more attention on. So yeah, so this thing of aiming at a safe version of technology, maybe from our current perspective, we're here. I'll take the case of artificial intelligence. We might think, well, we could have a fantastically powerful and dangerous artificial intelligence, which could end up causing massive damage. That's over here. And this is some kind of high-level representation of all the different capabilities and things which would have to be developed to get from here to here. Or we could have a really beneficial AI which could do loads of things and would be robust and safe and would be happy with it. That would be maybe here. And so from our perspective here, they look like they're pretty much the same direction. The things which are necessary to produce a valuable AI are many of the same things which are necessary to produce a dangerous AI. It's a lot about just, okay, how do you actually make a smart system in a computer? So it doesn't look like it's necessarily enough to just say, well, aim at this one, because from our perspective, the direction to this one is the same as the direction to this one. It's also worth thinking about, okay, so how maybe this goes to the bad and this one goes to the good. And we can try and think about what's the thing that's separating them. And so this direction is stuff that's pushing you from bad to good. And you can try and separate out what things would be particularly helpful for producing good outcomes and not helpful for producing bad outcomes. And those look like they may be the best stuff to build. Because maybe, I mean, if you might think, well, what happens if too much of this happens? We end up going off down here. But now, eventually, we circle back up, and it now becomes much more likely that we get to the good AI because it's closer than the bad AI. Again, this is a cartoon diagram. Don't read too much into the literal layout of things here, but I think it's pretty rough. Okay, let me say something a little bit about information hazards. So we've looked at, I've given you this argument for why this differential progress argument, which suggests that not all technological progress is beneficial. And more generally, we can ask when dissemination of true information is good or bad. And like, there's a general societal norm. We think knowledge and truth is good. We do have some exceptions to this that we think, well, okay, yes, but in that case, dissemination of true information is bad. I don't want all of the internet to know my passwords. And this is something that maybe we can go and try to understand a bit more. I've given a bit of a summary here there's a quite detailed paper from a few years ago from Boston where he looks at all the different kinds of hazards from spreading information. But the main sorts that I want to draw attention to are firstly cases where actually it's this kind of developmental progress which makes information look bad, but there is perhaps some knowledge which pushes in this direction, and although it's eventually that would be a good thing to have to add to this stuff and end up here, it looks like it may be more likely to move us into a dangerous region or onto a dangerous trajectory. There are other cases as well. There might be that something moves us to, like, that we have some fairly good norms at the moment, and now we have information which allows. So at the moment, online infrastructure is, we have a lot of stuff built on public key cryptography. If people develop some methods which would allow polynomial time factorization, that could mean that basically all of this architecture and systems was unsecure and didn't work anymore. And that could move us to systems which just work much less well for coordination than we currently have. You could have things where you can actually think there's malicious actors. So this can happen if you're the military and you're thinking about developing new technologies, you want to stay ahead of your opponents. But actually there's a degree of espionage and information leakage, and if you develop something, it may well be that other people will also get access to that technology earlier than they otherwise would have done. So this is a reason that you may want to hold back on developing something even if it looks good for you. Likewise, maybe we shouldn't be publishing information which is most likely to be helpful to terrorists or people aiming to cause a large amount of damage. So there's a controversy over whether the genome of the 1918 flu should be published online. It has been, but it looks like this represents an information hazard in that it could be harmful. And then there's also this point that actually information doesn't need to be, you can have things which cause harm and create an information hazard even if the information is already out there in the public domain, because you can pull more attention to it. You can get people thinking about it in different ways. So we can, maybe in the way it's communicated, maybe, so it's possible that even though the material which I've been talking about in this course on looking at existential risks and so forth is generally publicly available, that I have created an information hazard by telling crowds of people, because it might increase salience of these things. It might increase, maybe before, nobody would have been thinking about, causing human extinction. I guess that's the thing I could do. And now some people will think that. And you could cause damage that way. Or maybe it could create defensive backlash. There's been some worry that if people are talking about the potential dangers from artificial intelligence, that could make researchers into artificial intelligence go, hang on, this doesn't sound good. I work on this stuff, it's good. You shouldn't be talking about this because you could cut off funding and attention to this really important technology which is valuable. And you could create hostility there. And it might be that actually if we had less public discussion of this, it would be easier to have non-confrontational conversations and to get people more on the same page and get more understanding. So there are different ways that information risks that information can pose risks. I don't have all that much to say about that, but I think it's important to be aware of, and so it fits a bit with this discussion of the trajectory, so I wanted to add it in. But maybe I'll stop there, and then we can have questions, and then maybe some discussion. There's some questions I'd love to get people's thoughts on. Any questions on stuff I've said? Or...
All right, everyone. Just a sort of semi-throwaway remark you made that I was wondering if you could elaborate on. You were talking about how safe AI might help with other X risks, and you said in particular safe AI might help facilitate higher levels of coordination. Can you say a bit more about how that might work?
Yeah, so I can say a little bit more, but you might think that actually failure to coordinate basically comes down to some error on somebody's part, and that you should always be able to. There's a question of what trade point you actually reach, but between smart, rational actors, you think they at least always should be able to cooperate and not be left in the Pareto-dominated region. And maybe if both sides now have access to technology which helps them do this analysis much better, then they're more likely to actually reach one of these agreements and end up kind of cooperating.
I guess that's based on a kind of optimistic perspective on game theory. I mean, if you think there just are these situations that are structured so that rational actors, each acting in their own self-interest, will collectively bring about a suboptimal outcome, then it's not like any of these guys are making some mathematical mistake that a clever AI would have helped them not make.
I think that when you allow, I think that, like, to some extent, people are prone to errors of judgment, and there are issues about kind of bandwidth of communication channels. If you allow a lot of communication between people, and you also allow them to make binding commitments, it seems, to each other, then it seems like you definitely shouldn't end up in the Pareto-dominated area. Now, maybe I agree that I'm not totally confident about this. Maybe it will turn out we don't have plausible ways to make binding commitments.
But maybe this safe AI can help us figure out the smart things that we
Right. Maybe there are some smart ways that we can actually do to proceed along this. It doesn't seem certain to me, but it seems more likely than not.
So one interesting, more empirical question, which I think is worth investigating in the future, is, of course, do we have good examples where we have managed to actually do this kind of differential technology progress, where we actually managed to push, so we develop a useful thing ahead of time deliberately. There are probably quite a lot of cases where we later realize, oh, we were pretty lucky over there. But it would be interesting to investigate actually where we found that. I think there might be one historical example in the safety work that was being done just after the Asilomar conference. So people generally talk a lot about the Asilomar conference as being a wonder of self-regulation, etc. But the really useful thing was they recognized that they didn't know very much about some of the safety issues, and that should be a very high priority. So that was essentially the first thing many of the labs then went off to do, try to see if they actually needed a lot of biosafety. In fact, I think some of the biosafety levels were defined based on that work. They were also very concerned about some of the viruses they're using for transfection, because they were monkey viruses, so they might presumably actually be able to infect us humans. And again, there was interesting work on the viability and could they actually get out in the lab sink. So that was perhaps getting some of the safety jobs done earlier.
What's the conference that you referred to?
The Asilomar conference.
Yeah.
So this is kind of almost mythical by now. So back in the early 70s, Berg and others had published a paper showing that, look, we can put a new gene into the genome of a bacterium. And essentially everybody instantly realized that, whoa, this is a new era. We can actually modify genes. And everybody also very quickly realized that we have no clue what the implications are. So then, since this community was relatively small, it was possible both to get a voluntary moratorium, because almost nobody could use the new technique for a few months, and then they went off, all of them more or less, to Asilomar in California, and had a week-long conference about, okay, how do we think about this? By now, this conference has become an almost mythical example of scientists doing good self-regulation. There is this picture of them doing the right things, setting up the right rules. Although, looking back, it's pretty obvious that they missed things, like they deliberately didn't invite any ethicists. Because they maybe somewhat rightly realized that, yeah, we're not going to agree on ethics here. So there was very little work on the ethical implication. Everything was kind of totally safety directed. Throughout the 70s, most work on the genetic engineering was proving that this was pretty safe. They did some very smart things, like realizing right now we're very uncertain about it. Let's have very tough regulations that we gradually lighten if we think that we actually can lighten them, which turned out to be a sensible thing to do, except from a PR perspective, because by the late 70s, people started to notice that those scientists who have been talking about a lot of risk are no longer talking about risk. They're starting companies instead and saying we don't need that much regulation. So it was, I think, misunderstood by the public to some extent, and to the detriment actually of the biotechnology community. But overall, it was a pretty good attempt, but it's probably rather unique. It's not going to happen like that right now in Washington, where people are having a similar discussion about using CRISPR on human germline engineering, because you can't get the entire community together. It's too large, it's too diverse, too many different countries, and it's pretty likely that people will not agree. Even if they have a grand proclamation, it's not going to be as powerful. But it's still an interesting case where you actually had a sufficient community to do at least something somewhat useful. Sorry, mini lecture there.
Good. It's more than I know about. I have some kind of crude picture of it. So something I'd love to get some thoughts on. This is like an issue which we discuss some practical relevance here at the Institute. Is occasionally we face things which appear like they might pose information hazards, where people are looking at trying to in the course of trying to understand things which could cause very large amounts of damage to the world, so that we can work out how to avoid or prevent them. Sometimes you come across something which is new, it hasn't been discussed too much out there, and maybe discussing it would increase its salience or increase the number of people who know about that, and could turn out to be bad. What's the appropriate way to react in this case? So I don't know if anybody has immediate thoughts on this.
I think you have to talk about it and hope for the best, right? Because just as likely that there's someone who could take that piece of knowledge and do something bad with it, there's just as well as there's someone else who would take that piece of knowledge and do something even better with it.
So, and do you think like that's going to apply immediately? Like you might as well just make everything public, or?
Yeah.
I mean, so
I mean, if you,
I don't
kind
think
of that
so.
sort of.
And do you think this was true with the 1918 flu genome?
Well, I think the other, I suppose the caveat is that even when a piece of knowledge is released to the public, the subset of people who can actually do something with that piece of knowledge is perhaps limited depending on what it is. Like I would have no idea what to do with the flu genome. I wouldn't know how to turn that into a weapon as such, or turn it into, a vaccination.
Right.
So you've got like the overall 7 billion of us on this planet, the subset of people who can actually do something useful with that piece of information.
That's true now, but perhaps as we get better kind of biotechnology tools, we might end up with software which allows you to more easily say, oh, just print this genome, please. Now, there's still like printing a genome isn't going to be enough to weaponize, but it might not be that far off. So, like, it at least seems like.
But then you get to the point, don't you, that where like all knowledge at some point can be militarized and turned into something that's dangerous.
Right. So
So then you start going to. We end up having less coordination because we start. Oh, I don't want to tell anyone this piece of information because there's a potential that they may turn it into something against me.
I mean, my impression is that, like, normally as a default, it's good to share information, but that in some cases, it's probably more cautious and better not to. I mean, in the case of the.
But then you're making that judgment in your experience, which may be different to someone else's judgment in their experience.
So then you can try to have, build systems which actually access more judgments than just an individual's judgment.
Without sharing the information?
Well, you can share it, so it's less bad to share it privately with a few people than.
I mean, these two axes, they are always interlinked, right? Because there's always a time lag. You might release the genome, and then the small subset of people who is able to use this into a weapon that will take 5 or 10 years to do something with it. And once the information is released, I think there's then the coordination effort that kicks in within the 5 or 10 years. Hopefully, have a way of coordinating and using that knowledge and regulating it. And I think with nuclear, that's sort of the trajectory maybe that one sees. There's one step of progress, and then there's efforts to regulate that knowledge and to make sure that it's not used to destroy all of humanity. And of course, that's not always successful because the coordination is very difficult between the technological progress and so the supranational governance of that. I think it's hard to just separate the two. I mean, they constantly interact, and the one might be a little ahead. I think usually it's technological progress, which is slightly ahead of our capacity to regulate. But I mean, the regulators they know the technological progress that's going on, and they're constantly reacting on that. So I think it's.
I mean, it's not. I don't think it's correct to say that all information is like in expectation going to be equally good and as equally bad. If everyone had a general heuristic of if they thought the information could cause global catastrophic risk, not trying to publicize it, or not even trying to go and find out as much as they could about it, people would not try to gather the information to create nuclear weaponry, and the whole sort of very tense situation might not have happened in the past century. So I mean, I don't think it's the case that all information has like neutral value in expectation.
You can, so just to be explicit, there's maybe a range of intermediate things where you could say, okay, we're not going to publish this flu genome publicly, but we will publicly announce that we have it and set up a procedure so that people who want to engage on research projects can apply to have access to it.
Well, that puts a lot of trust into scientists.
Well, so
it tells you that they're not corrupted.
I'm not sure that that's like the right level to go at, but it at least seems a little bit better to me than the just put it on the internet, except for the overhead costs. But
there is, of course, an interesting analogy in the computer security. So if you discover a security bug in a piece of software, what are you supposed to do with it? So the practice that has come up now is very much you do responsible disclosure. You tell Microsoft that I found a way of escalating privileges in Windows. You better do something about it. And then you give them some time to fix that. Perhaps you should yell at them a bit more. And after a certain amount of time, you actually tell at least the security community. That's a practice that has grown up because previously people were just announcing it straight, and that was regarded as a bad thing. On the other hand, there have been a few cases where security researchers have instead been sued by the companies who don't like at all people finding that their products are really bad. This is an ongoing discussion that's been going on actually since the first locksmiths banded together against people pointing out how cracked the locks were. So there were some safes that were claiming to be really good, and there was an easy way of opening them. And that was kind of a secret known among the locksmiths. And when somebody published that, they were very irate. But you can argue that there is a public need to know that, yes, these safes are really unsafe. Now, of course, we have another problem. We actually have a market for exploits. A lot of intelligence agencies and other groups are willing to pay rather nice cash for a way of taking over Windows. So why tell Microsoft and the world when you can go to one of these markets and get some money from NSA or the Russians or whoever it is? Don't ask. So now you have created an incentive to really make an information hazard. So to me, that also suggests that you can set up institutions that help manage information hazard. Unfortunately, there are also kind of anti-institutions, things that make things worse. So maybe one should put in an effort in wiping out the anti-institutions. Maybe we want to figure out how to not have an exploit market for biology with kind of the worst hacks of microorganisms.
Yep.
One risk maybe also to take into account is not only how releasing information can be exploited by people who are in the know, but also how it can be used negatively by people who aren't informed. So one example I'm thinking about is geoengineering, where if the general public is led to believe that there is a techno fix for climate change, for example, then they will take more sensible steps, like actually, stopping out the source less seriously. So obviously one of the I don't think any.
So that's true if they're I think we was missing a qualifier. If they're mistakenly led to believe that there are good technical fixes.
Yeah, because I don't think anyone would argue that any of the geoengineering technologies we know of at the moment could solve the environmental problems associated with climate change completely. All of the ones that we're aware of have quite negative side effects, even if they do, solve the main problem of rising temperatures. But like one issue I've come across is the moral hazard. If you develop geoengineering, then for one way or another, people will not truly take on board the fact that it's not a perfect solution, and they will take, and they won't take actually stopping the root cause as seriously. So maybe that's another thing to take into account.
This seems right. There's lots of different ways that, there's there's lots of different ways where false information can cause harm, and so I want to be careful here, because it's like easy to see how disseminating the false information that geoengineering, or the assumed false information that geoengineering is a painless fix, would cause harm if it turns out not to be a painless fix. But then there's also this more subtle point that people will make inferences and guesses when they're not totally informed, and so you can disseminate the true information that geoengineering may be able to fix some aspects of the problem, and have people end up believing something like, even if not explicitly, geoengineering will be a painless fix, and then that can lead to and I think this is almost certainly this Bostrom paper on the different types of information hazard is quite comprehensive in listing lots of different sorts. So I expect that this goes under one of those categories, but I'm not familiar enough with it to tell you exactly which one it would be.
Yeah.
It lists about 20, 25 categories.
I can't remember which one it is. We discussed the geoengineering case in the unilateralist paper, which is also linking a bit to my issue about institution building. If anybody can do geoengineering, and somebody is likely to, the more we are, the more likely it is that somebody will do it, even though they're overconfident or have interpreted the evidence in a bad way. And this is assuming everybody's actually rational and trying to do the most good for work, not even assuming any selfishness or any other complicated and messy interests. So our suggestion there is, of course, that one should recognize that one is in that state and try to handle it. But when writing that paper, we had this very long debate, which I don't think is showing up much in the paper, but that's about epistemic peers. So if we represent different nations who have geoengineering capacity, and we're trying to decide what to do with it, should it just be us? Or should they actually invite the other stakeholders, like the nation of Owen, who haven't got geoengineering capacity, but happens to have a climate that's going to depend on what we're doing? So you might argue that maybe Owen is not our epistemic peer on the question, but he's a moral stakeholder, so we need to have him in, and probably everybody else in that case. At which point, of course, you end up with both a political problem and also a question, maybe we should actually keep it to an even smaller group. Some of us might be much better at evaluating this than others. Would it make sense for others to recognize that and say, okay, you decide for us? Which might actually be a very smart thing in a unilateralist situation, because you want as few an agent as possible who are as well informed as possible in that kind of situation.
But you could end up with a situation where, because they're so well coordinated, they have a group think, and then they totally miss some obvious risk because they're so tightly bound to one another.
I think we're seeing that in regards to the gain of function experiments in flu research. Essentially, some of the flu researchers are doing experiments that makes a lot of other people scream, but no, don't do that, that's horribly dangerous. And the other flu researchers are kind of closing ranks around the flu research work, even though the AIDS and Ebola researchers, who are very similar but have a different virus, are screaming, what you're doing is crazy.
Yeah.
So that produces a rather weird dynamic. So.
Yeah. And could that also then counter the argument earlier that always improving coordination is better? Because, like, yeah, which directions are robustly good? increasing, improving coordination.
Yeah, and the group, maybe you can avoid the groupthink by having coordination on making decisions, but not on the generating ideas. But it's at least
Yeah, okay.
something you want to be careful
Yeah,
about.
so you differentiate it. Yeah.
We've reached the end of the hour, so let's stop the big discussion there, but I'm happy to stay around and chat. Thanks everyone for coming. One other thing is, if anybody is a graduate student or postdoc and interested in a small amount of teaching, we had somebody ask if someone was interested in running a set of tutorials next term on the ethics of space exploration and artificial intelligence. Ask me about this and I can do it. Thanks, and you can get some more questions.
A really good taxonomy. Then it's hard to keep track.